Hey guys, so the homework problem I decided to do is from the body and the beam section and interference section. It's based off of this diagram where it has two identical speakers which emit sound waves that are in phase with each other. This circle right here represents a person seated directly in front of the speaker. So I did question number 2 of this section, which states each speaker emits a frequency of 660 hertz in phase with the other. The listener is seated directly in front of the speaker, 1.56 meters away. The speakers are 2.4 meters away from each other. How many extra wavelengths are needed for sound to get from speaker 2 to the listener? Take the speed of sound in air to be 343 meters over seconds. So what is given to us in this problem is x1, which is equal to 1.56 meters. This would be x1. I made another diagram down here, and I labeled this x3, which would be the 2.4 meters distance between speaker 1 and 2. And then they give you the frequency, which is 660 hertz, and the velocity, which is 343 meters over seconds. So what we need to find first is what x2 is equal to, and you can just use simple Pythagorean theorem, where you do x1 squared plus x3 squared and square root that, and that'll give you the value of 2.86 meters, which would be this value right here. And then to find the wavelength, use the equation velocity is equal to frequency times wavelength, and then you would get this equation. You plug in those numbers and you get the wavelength of 0.520 meters. And then it says x2 minus x1, since you're trying to figure out how many extra wavelengths are needed for sound to get from speaker 2 to the listeners, and this is you plug in these numbers, and that would be a total distance of 1.3 meters. Then you divide it by the wavelengths that you found up here, which gives you 2.5 numbers of wavelengths more.